All right. Hello, everyone. So today we will be covering the factory method design pattern. This is a type of creational design pattern. So we discussed three types of design pattern. Design patterns have been broadly categorized into three categories. One is creational pattern, then the other one is behavioral pattern, and the third one is structural pattern. Today we'll be covering factory method pattern, which is one of the creational pattern. Okay, but I'll not go into definition or I'll not force this design pattern onto you. First, we will see a problem and then we will analyze different solution we can take, and then we will see how a design pattern actually solves a problem. Okay, so it will be more into the practical approach rather than going to theory, because with theory you will not be able to understand anything about this pattern. Okay, so we will do the practical things in this, and let's see. Feel free to ping me if you feel any doubt or anything. Okay, let me share my screen and then we will start it. Okay, just a second. Okay, so first thing is, why do we use design pattern? Like what is the real advantage of having a design pattern? See, design pattern is nothing but a way to solve a problem. So we keep on getting different problems repeatedly, and design patterns basically help us to solve those problems, nothing else. Okay, so it's just a fancy name to say that we will follow a particular set of code, or we will write our code in a particular manner so that we will not get certain kinds of problem. That's it. That's the design pattern. Okay, don't get into the fancy definitions of it. It just, we use design pattern to solve the repeated problem we get while implementing our program, our application, our code, whatever it is. Okay, so to solve the repeated problem, we use design patterns. A particular, we set a couple, fixed a set of pattern, and then we write our code in such a way so that we will not get a problem. But in order to understand this, we first need to see how actually a problem happens in our code. Okay, so it is factory method pattern. Let me first share my screen. Okay, it is more like a notepad. Okay, let me create a new file. Okay, uh let me increase the size of it. Okay, it's factory method pattern. It's a creational pattern. Creational pattern, as I told you in the last session, basically is a type of pattern which helps you how you create the instance of a class. Okay, we have different classes, and different classes are dependent on each other. So we create the instance of classes, instance of another class in one class, so that we can call other classes from one class. Okay, so in order to make two classes dependent on each other, we create instance of those classes, we call them objects. Okay, and that's how these two classes becomes dependent on each other. Okay, factory method pattern, and for that matter, all the creational patterns, all the creational design patterns helps you how you create the instance of the classes. Okay, so the main aim is that they delegate the object creation part. Okay, it's more about using the abstraction. Okay, but we will not focus enough on the lingo. First we will see how it is, how a problem occurs, and then we will solve it, and then I will tell you about the definition, and so that you'll be able to make more sense about the definition. Okay, so first think of it as a company. Okay, there is a company, let's say Amazon. Okay, now Amazon company is obviously a very big company working on business. So they keep on getting different cases. They have different types of customer. Okay, and let's say they have created a support class. Okay, so in their support class, we have two methods. One is to get the SLA. Okay, because whenever anytime a customer raise a case, we have to get the SLA, like how many hours is the SLA time. And there is another method, let's say allowed tickets. Allowed ticket method basically gives you the number of tickets that particular customer is allowed within a, let's say, a year or month. Okay, so we have a class, public class admin basic support. This support class basically provides support, and inside this support class we have a method called public integer get SLA. Now this get SLA is basically returning the number of hours. SLA is basically the time on which, the standard time on which you have to solve a particular case. Okay, so let's say it is returning 40, which means every time a customer raise a case, we'll have to solve it within 40 hours or something like that. So get SLA method will do nothing. It will return the number of hours we have defined for a SLA. Then there is a method called public integer allowed tickets. This will return the number of tickets allowed for a customer. Okay, let's say it is 99. Okay, now this is working fine. Customer will raise the case, and the support people will work on the cases. So as a developer, you have written a method at a class. Okay, every time a new case gets created, okay, you will take the help of this particular class and method to define the SLA for that particular case. Similarly, allowed tickets will give the number of tickets allowed for that particular customer. So every time a new customer case comes in, support representative will basically see how many hours of SLA we have and how many tickets are allowed. If it is within limit, then he will provide support. Otherwise, he will not provide support. Okay. So a new case comes in, customer support representative will be able to see on the Salesforce screen that the SLA for this case is 40 hours. So you can build this functionality with the help of this class. So as a developer, you have built it and it is working perfectly fine. Okay, no problem at all. Now, whenever, how we will use this? So obviously we will have to use it somewhere in the in other classes, or how we will call this method is that we'll create the instance of this and then this call this method. So if I have to call this in the anonymous block, how will I write it? We will create the instance of it. Okay, let's call it support is equals to new admin support. And if I need to get the SLA, how I'm going to get it? Let's say we will call support. Let me integer SLA will be support dot get SLA. That's how we will get the SLA, right? Okay, and we will be able to use this method and we will get 40 in return. Everything is working perfectly smooth and we are able to work, and as a developer we have developed something which is working perfectly fine. Now the problem comes when we expand this system, when we try to when our company expands, we need to let's say after a year or so our company expanded a lot, and now we will have to introduce, because we are getting so many cases and there are customers who are demanding the express service, or there are customers who are demanding the premium support. So we will have to introduce something called premium support. In the premium support, SLA will be less because customer is paying, so they want their issues to be addressed quickly, and also they want to have more capacity, like they should be allowed to raise more concerns. Okay, so we've got this requirement that now that we have admin basic support, I have to provide something called premium support as well. Okay, which will have less SLA and more number of tickets. Okay, so let's say there was 99 tickets in normal admin basic. Now, as a developer, what I will do, we have admin basic support. So what I'm going to do, I will create another class, public class. Now I'll call it admin premium support. This is the class name, and then this will have same method. It's just that it will return the different value. Okay, so it will, let's say, return 12 hours. So within 12 hours, we'll have to make sure that we are solving the case. So this is going to be our premium support. Okay. Now, how will you call it? How will you use, how will you call this particular class? Similarly, you will create the instance of it and then call the method. But now you have two classes. One is admin basic support, other one is admin premium support. So when it comes to call these particular method, you will have to see whether you need to call the admin premium support, like the get SLA method of admin premium support, or the get SLA method of admin basic support. So when it comes to call these, you will have to check if let's say customer dot type is equals to admin basic. Let's say you have a parameter called type, which will identify if the customer is basic or the premium customer. Okay, so if the customer type is admin basic, then you will create the instance of admin basic support. Okay, else you will create the instance of admin premium support. Okay, so let me call it premium support. Okay, and then you can call the method of it. So okay, so now you will call the premium support. So let's suppose your calling part is on some other Apex classes. When you introduced a new premium support, you needed to create a new Apex class, which is fine. Like we can create multiple Apex classes, but the problem part is that you will have to change the code of calling class as well. Like from the class where you are calling this particular method, you have to make changes here as well, because now you have to introduce, if customer type is admin basic, then call this method, then call this class, otherwise call this class. Okay, and now let's suppose after all this thing, they again came up with something else called platinum support. So let's say a platinum support comes where the, let's say, SLA is only 6 hours, then you will have to create another class and method, and you will have to again change the code of calling. You will have to write it in a way that if customer type is admin basic, then do this, else if customer type is premium, then do this, else then call the premium support. And this is just one method. This is just get SLA method. In a real application, there'll be hundreds of method. Okay, creating a new class and creating new methods inside is not a problem, because that is okay. Like we create multiple classes and method. The problem is that every time we create a new class and method, we will have to change the existing class which is calling these methods, which is calling these classes. So this particular way of doing thing is fine if we have very few requirements, and if we have if we do not keep on getting extended requirements, and if we do not have multiple methods. But if our requirement is something which we need to scale on a higher level in future, then we will have to build it in a way that it is scalable. Okay, now let's say if we'll have to introduce premium support. Sorry, premium is already there. Let's call it platinum support. Then you will have to again create a class. Let's copy it. I first want to focus on this fact that I want you to understand the real problem first. Then we will talk about the solution. Okay. So we will call it platinum support, and let's say SLA is only 6 hours, and you are allowed to create, let's say, 500 records. Okay. Now this part where we are calling it, this part also need modification. Okay. So if customer type is admin basics, then do this. Else, if customer else here you need to write if customer dot type is equals to, let's say, premium support. Okay, then you will do this. Else you will call the platinum support. Okay. Okay. So you see the problem here. You need to create new class, which is okay, but then you will have to change the part where you are calling as well. So this will be an existing class which is using the existing code. So what happens normally is that in a live application, we prefer not to change a class which is live. Okay, now you will have, because when you add some functionality in it, let's say you added only this part. When you add some functionality in it, you will have to test the whole functionality which was earlier working perfectly fine. And in a large application which has thousands and thousands of line, if you get to test everything by just by adding a 2 3 lines of code, then it will be a too much of technical depth as well. Okay, and we can already see that this is not a very scalable solution, because let's say in future now they comes up with something called gold support, okay, or a diamond support. Then you will again have to create a new class and new methods, and then you will have to change the calling part as well. Okay, so the here you will have to add another else statement and another if statement. This will not be very feasible because this adds so many problems in your code. You will have to test a lot, you will have to keep on changing the existing class, you will have to create the new class as well. So there are so many problems. Okay, any doubt in problem part? Like, are you able to understand the problem part, guys? Also, one such problem is that these classes have common methods. Yet, I mean, now a new developer can call it get uh, premium SLA or something like that. Even if he changes the name of it, you will have to change the name here in the calling part, and I mean, the class structure will also not be unified. Okay, so we have to solve all such problems, but let us first write down the problems. One, we will have to create new classes every time a new support type is added. We will have to change code on calling class, like add new if else statements every time we add new support type. We will have to take care of class structure. structure manually. We'll have to tell the developers that we already have an admin basic class. You need to follow the same structure we are following in the admin basic class. Otherwise, he is free to write his own method. He is free to change the method name. Okay. Okay. So these are the couple of major problem. This is not a scalable approach because in real systems there will be hundreds of methods, and creating, changing main class every time will not work. Okay, calling class is a class which we can call a main class because that class is calling all the classes: admin basic class, premium base, the premium support class, platinum support class. So main class will be calling all such classes. Okay, so obviously this will not be an scalable approach because uh, we'll have to change the main class every time, and every time we change the main class we will have to test the whole functionality. Okay, which is unrealistic. Like if there is 1,000 lines of code and you added 3 lines, yet because of those 3 lines we'll have to test the whole functionality, that will not make any sense. Like testing will be a huge task. Now coming to the solution. We'll address each problem one by one. So first problem is, let's start with very basic problem, the class structure. How can we make sure that every class follows the same structure, copies the same method, and the method name is same? That is very common. We use interface for that, right? So we create an interface and then we inform developers that you will have to implement these interfaces every time you create a new support class. Okay, so let's say I created an interface, public interface I admin support. I basically says that this is an interface. Okay, all right, and this will have two methods, signature of two methods, get SLA and allowed tickets. This is to make sure that every class follows the same structure and provide bodies for these methods. Anybody has any doubt till now? I know this is bit off topic. This could be bit complex for few of you, but bear with me. It is an easy thing once you go through everything. Now, what about, yeah, please go.
Yeah, sorry, right to interrupt. Mohit, like in the provided class, right, for Platinum or the other versions, like different supports for Premium and Platinum.
Hmm.
Here, the basic thing is like it should support only the mentioned method, whichever you have. Like suppose for Platinum, it is having an extra method, then
Hmm.
it won't work, right? How it
Sorry, can you repeat again?
uh, here in this scenario, like for premium support and admin basic support, uh,
Mm-hmm.
both are same. Like in that having only the return values are
Yep.
different.
Yep. Yeah, return values will be different. Yeah,
Yeah.
right.
For platinum support, think that one more method it is introduced.
No, 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 no.
So
If
in that scenario,
Yeah, if you want to add another method, let's say in the platinum support, that is fine. That is, you can obviously add even with the interface as well. So that is completely okay. If you want to add any other method, let's say in the premium support, you want to give them free delivery or 1 day delivery. So we can create another method in the platinum support, and that will be only for the premium support class, not will not be available in the admin basic or the platinum support. That is okay.
Okay. Okay. Yeah.
Yeah, that is completely okay. And it is fine even with the interface as well. If we want to create our own method in the class, interface never force us to only use the method given in the interface. It will say that you'll have to provide the body for the methods I am forcing you to, but you are free to create your own methods as well. Okay. So first thing is that there was a problem related to we'll have to take care of class structure, because let's say in the admin basic we have get SLA and allowed tickets, but another developer came and he worked on the platinum support. So for platinum support, he, instead of creating the get SLA, he said that get number of hours. Instead of writing the method name as get SLA, he wrote get number of hours. And because he feel that get number of hours make more sense. So there'll be no structure in the different classes, even though they are pretty similar in terms of how they work. So as an architect, it will be my responsibility to enforce a kind of structure every developer need to follow while creating a class, because they are almost similar classes. They are in the same type of classes. Okay. So as an architect, what I will do in my company, I will create an interface like this, and I will ask all the developers to first implement this interface, so that you will have to provide body for these methods. Okay. If you want to create some of your own methods inside the class, you are free to do that. That is not a problem. Okay. So now once we use the interface, once we create an interface, we will have to change our classes structure. So now our public class admin support class will have to follow class need to implement interface. Okay. So I'll have to implement admin support interface. And similar to this, platinum support and premium support classes also need to implement the interface. Now, with the introduction of interface, one problem has been sorted, that we'll need not to be worried about the class structure, because now every class will have these two methods. Any class we want to create for any kind of support, premium support, gold support, diamond support, every class need to implement this interface, and this interface force us to provide body for these two methods. So one thing is sorted, that is the class structure. But the main class which is calling these different classes is still still has some problems, because even after we create the interface, the way we call these classes remains same. So I'll write it down like this. Calling part. Okay, this is the code written inside the main class. It remains same, but it will have some changes. Like I can do something like this. I'll create admin support as equals to support null, and then I can write if customer dot type is equals to admin basic, then support equals to new admin basic support. Now understand the difference here. What we did earlier was, when we were calling this admin support, what we were doing, we were creating the instance of the admin basic support class, and then we were calling this. Even when we had this if else statement, what we did, we checked if customer type is admin basic, then we created the instance of the admin's basic support class, and then with the help of this instance variable, we were calling the get SLA method. Okay, this is what we were doing earlier before the introduction of interface. Once we introduce the interface, the difference it will do is that first you can create you can write it like this: interface and then instance variable of the interface, and then it should be equals to null, because you cannot you cannot create the instance of the interface directly. But what you can do here is that this is the instance variable for the interface, yet you can write it equals to the class. So what essentially it is doing is that you will not have to initialize it again and again. You will not have to create the instance of your classes again and again. Like, you need not to write it like this. Admin basic support, my support is equals to new admin basic support. You need not to write it like this. Instead, what you can do, you can just create the instance variable for the interface and equalize it with the kind of class you want to call. Okay, so here, this line you need not to write. So if customer type is admin basic, then your support will be equals to the instance of the admin basic class. Else, if customer type is equals to, let's say, premium, then your support will be equal to new admin premium support. Okay. Else, it will be equals to admin premium support. Oh, sorry, platinum. So your code has been reduced bit because you need not to create instance of the class again and again like this. It has been reduced a bit, yet it is still not good enough, because you will have to write multiple if else statement. Okay, you will have to compare the solution with the exact problem we had earlier. So what problem we had? We'll go through the problems again. We'll have to create new classes every time a new support type is added. This actually is not a problem. This is fine. We'll have to create new classes every time, because when we add new functionality, it is okay to create new classes instead of adding the same functionality in the previous classes. The real problem lies in the line 2, where we'll have to change the code for the calling class. Like for the main class, we'll have to change every time. Okay. And we still have those if else statement. So every time we add a new support type, we'll have to again add if else statement in the main class. Okay. So to get rid of this problem, the solution comes in is the factory method pattern. So till now, whatever you saw is just the magic of interface, but now you will actually understand the real magic of interface. Then comes in the picture the uh, factory method pattern. All right. Okay, what I'm going to do, I'll create a class and I'll name it admin support factory. The main aim of this class is to handle the part of this instance creation, like for which support type, which class I'll be calling. For admin basic, I'm calling admin basic support. For premium, I'm calling the premium support class. For platinum, I'm calling the platinum support class. This admin support factory class will take care of the instance creation part, so that your main class need not to be worried about which class I need to call for the which customer type. You will just pass the customer type to this factory admin support factory class, and it will return you the instance of the class which you need to call. So in a way, you will add a layer of abstraction in your code, and your main class need not to be worried about what is happening underlying those abstraction layer. How it will do? Let's see. Okay, so this class will have a method. Let's say uh, public static, and this will return the instance. This will return the interface. Okay, in a way, it will return the instance of a class. Okay, an interface can be equalized to an instance of the class, and if I'm returning an interface, that means it can return the instance of a class. We have seen it here. We have equalized the iadmin support equals to a new instance of a class. Okay, so if I return an instance of a, if I return the interface, that means I can return the instance of a class. That is the magic of interface, and that is the real reason why we use interfaces in object oriented programming. Okay, let's say we name it as get instance, because this will be returning the instance of the class. What we'll have to give as an input? String customer type. Okay, we can call it support type, customer type, whatever. And now again, let's create the instance variable for the interface. Let's call it support, which is equals to null. And if now all the if else logic will be moved to this factory method. Okay, so if let's say support type is equals to uh, admin basic, then you will return the, then support will be equal to new admin basic support class. Okay, else if it is equals to, let's say premium support, forget about the spelling, then it will be, then your support will be equals to new admin premium support class. Okay, else it will be equals to, support will be equals to new admin platinum support. Okay, and at the end, what you will do, you will return the support. Okay, so it will either return the platinum support classes instance, it will either return the premium support class instance, or it will either return the admin basic support class instance. And every time you will have to add a new support type, what you will need to do, you will need to create a new class and method, and then you will have to just change the admin support factory class. Now how will you call it? When I'm saying this factory support class will add the layer of abstraction and all, it will basically promote a model where you need not to actually call the you need not to actually call any of the uh, classes. It will be handled by the admin factory support class. Okay, so that is the real benefit it will add. Okay, anyone?
Admin, sorry,
I will show
Mohit,
you.
there is one correction.
Sorry.
There is one correction, like the parameter name should be updated, like as per
Yeah, yeah.
support.
See, I want you to you guys to understand what it is. It is okay. Yeah, it should be support type. Okay, call it support type, admin type. That is why I'm not writing in the developer console, because it will give so many errors. And I want you guys to focus on the real problem we are trying to solve. I mean, syntax wise, uh, it could be something different as well. Like I'm not actually following any particular structure. Now, with the help of this factory method class, your main calling part need not to be worried about it. So here we'll not need to write these things down. Okay, we will just need to call what we need to write. So we need not to be worried about anything. When we just need to do this. Okay, uh, create an instance of this iadmin support. This is the calling part. Okay, and even we need not to do it null. Just call the admin support factory dot get instance, and here you need to provide what it is. Either it is uh, premium support or whatever it is. Okay, so now your main class just need to write this in order to get to know which class it will be calling. Your main class need not to know about what it is doing in, in the back end, what this class is doing in the back end, how it is fetching the instance. But now if you will call this, it will give you this in return, new admin premium support. So now you will use this class, and this class is SLA to get the number of hours you need to solve a particular ticket on, rather than worrying about if it is this, then do this, if it is this, then do that. That if and else part has been handled in the factory class. So with the help of factory method pattern, you kind of added an abstraction in your implementation, in your support implementation, and that abstraction is actually solving a lot of problem. Now if you will have to introduce a new support type, what you need to do, you need to create a new class and method and do some changes in the factory method pattern rather than your main class. Your main class need not to change anything. Okay, whatever you are passing as a support type, you just need to add in your factory method. Okay, so in this way, your main class need not to be worried about anything, what is happening in the back end. It adds a layer of abstraction. It solves a lot of problem. You need not to make a lot of changes in a lot of other classes, and your application will run smoothly, and it will have a less error prone as well. Okay. So that is the advantage of interfaces, and because of the interfaces, this factory pattern is able to do all those things. Otherwise, without interface, it will still remain same. So that is why interface is so important. What we as a Salesforce developer feel, what interface is, that it is just a way to force us to use these method, but interface is way more than that. You can see what interface did for us here, what interface did for us here, what interface did for us here, and it can be a return type as well. So it returned an instance of a class. It is all the magic of interface only that we will be able to do any of these things. Okay, now I will be giving you notes of this thing, so you need not to be worried about taking any of this thing in example or something. I have written it down in my notes, and I have those notes completed in front of me. So don't worry about copying it or something. Just my only request is that whatever I told today in the factory method pattern, please go through one reading, two reading, three reading, try to understand what it is trying to say, and then try to do it practically. If you want to do it in your dev org, or if you want to do it in the VS Code or anywhere, try to actually see if it is actually bringing any advantage or not. First, try to see actually what was the problem, and then try to see if we were able to solve those problems with the help of this factory method patterns or not. And if in case you're not able to understand, which is okay, I mean, I'm not expecting any fresher to, get to hold of this topic in first attempt. That is completely okay. We can repeat this, and you will get my notes right after this call, maybe in an hour, because I'll have to scan it and then send it. And yeah, In the next session, I'll be talking about the singleton pattern. Singleton pattern is also a creational pattern, and after the factory method pattern, singleton pattern is the second most important pattern we use in the Salesforce. Okay. Now, it's okay. We done with this topic, and we can take the questions on this in the next sessions as well, because I don't I don't want to rush this topic. I want you to, even if you understand one design pattern, that will be sufficient for you in an interview. Trust me. Even when they ask what is design pattern, even if you explain it properly, and then you can chime in a couple of things about factory method pattern and how it works, how it actually solves the problem, interviewer will be, will be flat on you. He'll be really impressed, impressed with you, because whenever somebody explains a design pattern, sometimes even the interviewers don't know what design pattern they're talking about. Okay, I remember my interview in the Coursera. I went for the interview, and then senior architect was taking my interview, and I explained solid design pattern, and she was like in an awe of how I explained solid principles. Like, nobody explains solid principles. They all know what it is, but nobody explain that. But I want from my student that you should be able to, because these are fundamentals of computer science, not entirely dependent on Salesforce or something. Even if tomorrow's technology changes, then also these things will still be relevant for you guys. So focus a lot on solid principles and design patterns. These are the factors which will make you stand apart from other candidates. Like, there is a candidate who can write triggers and flows and everything, and then comes you in an interview who explains what is design pattern, how it actually solves a problem, what are the solid principles. Then they'll see that this is a candidate who, after a year or two, maybe become a senior developer and may become an architect for us. Okay, so this is a huge change and huge topic which will actually create a lot of difference between you and the other candidate. I like these design patterns a lot, basically because of obviously the experience, and I needed to prepare these topics when I was trying to get a job as a senior Salesforce developer. And anybody who has more than 5 years of experience, these topics are kind of must-to-know topics for you. For junior developers or for people who have 3 years and less than experience, these are good-to-know topics. These are the basics of computer science. If you know it, you will become a better developer in future. Okay. All right. Enough of now coming to your questions. Feel free to ask your questions now, guys. We only have 11 participants, including me. So let's see if you guys have any question.
Sir, let me know, like, what is solid principle in OOPS? Like you usually told, like solid principle. I don't know.
Yeah, we covered it in the last topic, Navneesh. Did not you cover it? It is available in the X Factor topics. You can cover it. Okay. We have covered it in the last session.
Okay, okay. I think yes.
Yep.
I
In the X Factor topics, you will be able to see this. Okay.
okay, sir.
All right, guys. I thought that this will take more time, but because we did it practically, it did not go much on the theory. So we were able to clear it early. So for the theory, I have created my notes. If you want to know the definition of what is creational pattern, what is factor design pattern, and the theoretical part of it, how to answer it, it is available in my notes. But I wanted to focus more on the theoretical part and the problem part. First, you need to understand the real problem, then only you will think about the solutions. Okay. All right. Because of the odd timing, I don't think we have got much attendance today. But anyway, it was a good session, and I want everybody to go through this. Let me also stop the recording. Guys, you have any other question you want me to get recorded?
Yeah, hi Mohit, Zakir here.
Yeah, hi Zaki.
Just one question. Actually, in that interface, yeah, I just created one instance of all those classes. Then in the abstraction as well, you have created the instances of that classes. Is it required to create in interface as well?
Sorry, can you repeat it?
So in that, can you open that notepad, please? Can you share that one? So
Yeah,
I thought,
just a second. Yeah.
can you go to that interface, please? Yeah, here itself, interface, right? Yeah, this one. So if you see, you have created the instance of like a support equal to new admin basic support.
Yeah.
So in the down as well, in the admin support factory, you have created that instances. You are checking there the.
No, this class is something which I commented, like we need not to do it like this. Instead, we will be doing it like this. So that this is what interface is bringing in the table, is that we need not to create the instance of the class. Rather, we will create it like this, and then use this particular instance variable with the class. Okay, so this line is not an actual line. This should be removed. This is commented line. This I wrote just to tell you the difference, that we need not to do it like this. Instead, we should be doing it like this, because every of these admin basic support, premium support, and platinum support class have implemented this interface. So I can write it like this, and then I can equalize this support to any of these classes, because all these three classes have implemented this interface. So we need not to write it like this after implementing the interface. This is what we were doing before implementing the interface. Got my point?
Okay, okay, okay.
This is line I wrote just to do the comparison, but this will not be the line in the code actually. When you will write it in the developer console, this will always be commented, because this is what we are doing here. This is what we'll be actually doing rather than this. This is I wrote just to do the comparison. Like instead of doing this, we will do this. Okay.
Okay, okay. Thanks, Mohit.
This is a line. Okay. And don't worry. Yeah. Yeah, hi,
Hi,
please.
yeah, hi Mohit. Santosh here.
Yeah, hi.
Which design pattern is you used to use in Coursera, or
Okay, Coursera. See, we are using the just one framework for triggers. For classes, we are not using any design pattern. And you know, the good thing and the bad thing both about design pattern is that if you use a particular design pattern which is not solving your problem, then it is an anti-pattern. So be very sure about when you should only implement a design pattern when it is actually solving a problem. Design patterns looks very fancy. It looks like they are doing a lot of work and all, but unless they are actually solving a real problem for your project, it's not a mandatory thing to write down a design pattern or implement your classes in a way. So in our case, we have a trigger pattern, RF lift trigger pattern, and that is solving most of our problem. For the classes, we did not feel any need of implementing any design pattern, because I did not see any advantage of it. I mean, there is no any problem which we keep on getting on the repeated level or anything like that. So I don't think we have used any design pattern. Neither it is a mandatory thing to implement a design patterns. Unless it is actually solving a problem, we should not be using any design pattern. But yes, there are a couple of instances where we are using singleton pattern, where we are using the factory pattern, but on a very small scale, like not a very huge scale.
in a multi-threaded environment, like Salesforce uses multi-threaded environment, if I'm correct. So in that scenario, creation of an object, it will take a lot of resources. So in order to avoid these things, these patterns were introduced. So,
Yep.
yeah. So if we are creating simple class, or accessing simple methods and all, I think as you mentioned, it is not necessary.
Yep, definitely. See, unless any a design pattern is not solving a problem, it becomes a anti-pattern. So if you have implemented a design pattern which is not actually solving a problem, then it is actually increasing the complexity of a system. It becomes bit more difficult to understand a system unless it is actually solving a problem. So design pattern and design anti-pattern both are same. There is nothing called design pattern, to be very frank. It is just when we keep on getting a repeated problem, we kind of define set of instructions, like we need to follow this in order to avoid this, and then those set of instruction becomes the design pattern for us. That's it. It is as simple as it is. So if your org is a small org, your org is not facing any problem, there is not so many classes which are interdependent on each other, there is not much complexity anyway, then there is no need to add the layer of abstraction in between. Like Salesforce also handles a lot of abstraction on its own as well. So we need not to worry about design patterns a lot. For a developer, like for all the people who are around 4 or 5 years of experience and wants to scale up in their career, see, do not see, design pattern is an overhyped topic. Okay, it's a overhyped thing. We do not get to see those many problems which can be solved by design patterns. It is my personal experience. I have never implemented any particular design patterns in a way to solve a problem. If an org already has a pattern, we would have used it and all those things, but we hardly get to create any design patterns from scratch. And there is no fixed set of like we have 12 design patterns or 15. There is nothing like that. Any problem which we keep on getting on repeated basis, we create a set of rules. Those set of rules becomes a design pattern. So now you go to your company, Santosh, and you create those such a set of rules that will also become a design pattern for your company. Okay, so there is nothing called this is a fixed design pattern, this is. But on a broader scale, they have covered these design pattern in three subcategories or broader categories, and then they name it in a way that these are doing this, these are doing that. But there is nothing like this is fixed, like this is the only design pattern you will be using, or this will solve this. There's no guarantee. Okay, sometimes design pattern adds so much complexity in the system that you start getting governor limits, because it is written in a way that it will become almost impossible for you to use them. So design pattern also adds a lot of complexity to your code, and your code also becomes a bit complex to understand and read. So first, see if it is actually solving a problem or not. Sometimes you have written, let's say, a lighting web component. Okay, there is parent and there is child and there is subchild and all. So every child should not be able to call the grandparent or the ultimate parent. Every child should only be get to call the immediate parent. So you have created a rule that any child class will not class any grandparent or the ultimate parent. It can only call one level up class. That's it. That's a rule we have created in our org. So that then it becomes a design pattern. Anybody breaches that design pattern should be stopped. So you should write your code in a way that anybody should not be allowed to call the ultimate parent class. Okay, so then it becomes a design patterns. There is nothing called fixed thing. Like this is not a uh, set of rules defined by Salesforce, to be frank. Okay, so
If I am correct, like in my previous, like, we didn't get chance to write this design pattern. Like
yeah, yeah,
architects who design these things, they will create one ultimate thing, like how the flow should be,
yep,
uh,
yep.
should be done. Only thing is we used to access those things, and wherever it is necessary, we used to do that. We need to follow that blueprint.
Yep. The only reason why I wanted to show you by actually writing the classes and code is to show you the power of interfaces. Like how, because we as a Salesforce developer never get to write interfaces in our org. The most interface we use is the batchable interface. That's it. Unlike other asynchronous interfaces we use, but we do not get to create a lot of interfaces from the scratch. And that is why when I take interviews, most of the people have no clue about interfaces. They just say that it is because we have to enforce the methods on the classes. And when we learned that when we were discussing the solid principles, there was a I interface dependency. Like there was fourth principle, interface dependency, which says that any interface should not enforce the methods on the classes. Like a child class, if he does not need any of the methods written in the interface, then we have to subdivide those interfaces as well. So because we do not get to create those things, we cannot relate to those things. Because if we'll not get to write those things, or if we'll not get to think about those things, then how will we able to relate to those solid principles? So the main intention was to show you how interface actually works in large organizations. When we actually build some design patterns, then interface plays a very vital role. And that is why all the architects focus a lot on the interfaces and the object oriented concepts. Okay, it is either the freshers who can tell the object oriented concepts very well, or the the most experienced people. All the middle people always mess up with the object oriented concept, because we do not get to write those things, we do not actually see those things in the real time life. So don't take design patterns too seriously. It is a good thing to know. It is a good thing to sometimes flaunt in an interview. If you know, let's say, factory design pattern, factory method pattern, flaunt it in an interview like a pro. But
X factor. The
yeah,
X factor.
yeah, it's an X factor, obviously. Solid principles, factory patterns, all the other singleton patterns, these all are the X factors. These are the factors which even the interviewer might not know. Because I have seen that in real interviews, that even the interviewer were in awe with how you explain those solid principles. Because from his face, I knew that he has no clue about what I'm going to say or what I'm saying. Yet he knows that how important these things are. So don't take it too seriously, flaunt it in an interview like a pro. Like that's the reason why I'm telling you, otherwise I would have skipped this topic. It is not a mandatory thing for me to cover, but I know how impactful this can be in an interview. That is why I want you guys to just nail the interview with these topics.
It is helpful, Mohit,
Yep.
actually.
Yeah, definitely. See, if in an interview you explain it in the way I expect you to explain, you will nail the interview. No matter which company's interview you might be giving, you will nail the interview. So flaunt it, take the advantage of these topics, and then when your time comes, then learn it thoroughly, learn it properly, and try to implement it as much as you can. Okay.
Yep. Yeah.
Perfect. Thank you. It was late evening Sunday, so I I took your Sunday evening. Sorry for that, and thank you all for joining.
Good
It
product.
a very good productive session. I like these sessions where I get to write code and then get to explain code. So I feel very good about these sessions, because in the interview, I most of the time get to explain topics rather than actually doing. So it was good, lovely. We will cover the singleton pattern next time. That is also very important. I think if you cover these two, then it will be more than enough for your interviewer. All right. Thank you. Thank you, guys. I'll see you in the chat.
Mohit, yeah,
Thank you.
just one quick thing.
Yeah, please go
Uh,
ahead, Akash. Yeah.
yeah, Mohit, regarding notes, where do we have all the notes? Like in some of these sessions,
See,
I usually go through the recorded sessions only, and
okay. In Graphie, I've created one note section in the end. I think all the notes are not there, but I have my notebook with me with all the.
okay,
So don't worry. I will scan it and send it to you as a. See, I am sending individual notes for each topic, but by the end of everything, I think, scan all the 300, 400 pages which I have, and then it will be one single note for you guys. Okay, so don't worry about it.
okay,
Okay.
thank you.
Chalo. Thank you guys. Have a
Thank
lovely.
you, sir.
Bye
Good
bye.
night.
Good night.
Thank you.
Bye.